Hello there. In this video, we are going to look at the math behind savings and investments, particularly about how your investments grow with time through the power of compounding. Okay. To start with, let's consider an example where you want to save up for your retirement. Let's say you've got 30 years to go, and let's assume that you can potentially grow your investments at 10% every year. Okay. And to have a nice retirement, you probably are looking at $3 million at the time of your retirement. Okay. Now you've got 30 years to go and you want to calculate what's your monthly investment in order to reach that figure of 3 million down the line. Okay. So to do that, you're going to use the financial function PMT, which stands for payment. Okay. And it takes the following arguments: rate as in the interest rate, NPR is the number of periods, PV is the present value, in this case we don't have a present value, FV is an optional argument, which is the future value. We do have a future value here, 3 million down the line after 30 years is the future value. Type is another optional argument, which by default assumes the value of 0 when the payments are made at the end of each time period. If the payments are made at the beginning of each time period, then type has to take the value of 1. So because we are going to be investing at the beginning of each month, we'll have to use 1 as the value for type. Okay. So let's start with the rate. The interest rate here is 10%. Because we are investing every month, we're going to divide that rate by 12 to get the monthly interest rate. The number of periods is 30. Again, we need the number of months. So I'm going to multiply the number of years by 12. The present value, we don't have 1. So I'm going to put an extra comma there to reach the future value. Future value in this case is 3 million. And type has to be 1 to specify that the payment is being made at the beginning of each time period. Okay. So we need to make a monthly investment of $1,316 for 30 years, hoping that we get a return of 10% every year in order to reach the magic figure of 3 million after 30 years. Okay. To look at this in more detail and understand how your investment progresses with time, let's look at what happens to your investment every month through the course of those 30 years. Okay. I've created a template here for 30 years so that we can understand better how our investment progresses with time. Okay. At the beginning of the first month, the investment we make is $1,316. Okay. I've created a separate column for cumulative investment to add up just our investment without any interest. So in the first month, it's just what we have. How much is the interest being earned for the first month? That will be 10% divided by 12 because we need the monthly interest rate, multiplied by how much is being invested. Okay. So we have another column for cumulative interest earned, which adds up all the interest earned every month. In this case, again, it's just what we have for the first month. And the value of our investment, the total value at the end of month 1, is given by the investment plus the interest earned so far. Okay, let's look at what happens in month 2. Okay, so again, in the second month, we make an investment of $1,316. Now the cumulative investment is the sum of what you invested until the previous month plus the new investment. So far, you've invested $2,632 over the 2-month period. Plus, you also have the interest earned from the first month. So you would earn interest on your investments plus the interest from the previous month. So how do we do that? So what's the total amount of our investment so far? Is I add the interest earned so far plus the investment so far. And that grows at 10% per year. So divided by 12 gives you the interest earned during that month. Okay, so what's the cumulative interest earned so far? The interest earned in the first month plus the interest earned in the second month. Okay, what's the value of our investment now? Again, it's the overall cumulative investment plus the cumulative interest. Okay, so before I drag this formula all the way down, let me fix some formulae, the referencing for the formula here, so I can continue dragging that. Okay, everything else should be fine. Okay, I've already created this template to go as far as 360 months, which is 30 years. Okay, so let's see how our investment progresses until then. So at the end of month 360, you can see that our investment is worth 3 million. Okay, so to better understand what happens in this table, let's try to graph it out so we can visually see what's going on. So I'm interested in how the investment particularly grows and how also the interest earned grows. Okay, let's take that. Let's take all of that. I mean, if it's out of scale, we can try to remove some of the variables. Okay, let's see what's going on here. I'm going to remove the monthly investment. I'm going to also remove the interest earned. Okay, now we have three variables which are of interest to us. Look at the cumulative investment, which is the orange line, which is the $1,316 invested every month. You keep investing every month, and the sum of those investments grow at this particular rate. If you look at the yellow line, the cumulative interest earned, this is where the power of compounding kicks in, right? So the interest you earn, as you can see, is below the orange line until a certain period, and then it just shoots up and it starts growing exponentially, right? The overall value of the investment potentially is the sum of the orange line and the yellow line. Looks like it reflects more the yellow line rather than the orange line, right? So it depends mostly on the cumulative interest earned. Okay, to understand the power of compounding in much more detail, let's look at an example where we are investing for different time frames. Okay, so for example, let's say you could potentially invest only $1,000 every month. Let's keep the same rate of interest that you could grow your investment at 10%. Let's look at three examples where we are saving up for, let's say, 20 years or 30 years or 40 years. Okay, let's assume that we save for 20 years. What would be the value of our investment at the end of 20 years? For this, we use the future value function. The interest rate has to be divided by 12 to get a monthly interest rate. The number of periods is 20 multiplied by 12 to get the number of months. Then the monthly payment is 1,000. The present value is optional type, has to be 1 because we're investing at the beginning of each time period. Okay, so if you invest for 20 years with $1,000 every month and your investment grows at 10% every year, your investment at the end of 20 years is worth $765,697. Okay, now let's say if you do the same thing, but instead of 20 years, you're investing for 30 years. You get way more than $765,000, right? So that extra 10 years results in growing your investment to almost $2,279,000. Okay, let's say what happens if you invest for 40 years. Now your investment grows to $6,376,000, right? This clearly shows the power of compounding, that the longer you save or you invest, your investment has the potential to grow at a much higher rate. Okay. With this, we conclude our video on savings and investments. If you really enjoyed this video, check out the other video on mortgages and how a loan amortization table is made. Cheers.